All right, ladies and gentlemen, we are going to go through this review and you can just watch the parts that you need help with. Some of these solving problems were assigned a while ago, so you might need to go back and just make sure you still know how to do those. I'm going to notice here that this has a sixth power, so that means that I will eventually need a plus minus because 6 is even. First move is going to be to divide by 7, and when I do that, I get 140.71, and I'm paying attention to my instructions. It says 2 decimal places, so I know it's okay to get decimals. Here's where I'm going to introduce that sixth root, and when you do that, you need to toss down a plus minus because it's even. Keeping in mind you want to practice doing this on your calculator, you either need to be able to type in the sixth root of 140.11, or you can type in 140.11 and raise it to the 1/6 power. When you do that, in this case, you get about plus or minus 2.28 rounded off. Be really cautious about that because you want to do what it says to do when it comes to rounding, especially if you're taking an online test. In this second one, the first thing that I need to do is square both sides. And so this square cancels this one. And I actually have to go through and FOIL this. So this is going to turn into x squared minus 6x plus 9. Now it's a quadratic, which I can only solve if it is equal to nothing. So I am subtracting that 4x from the negative 6. Now I'm going to check and see if it factors, or else I'll have to use the quadratic formula. To get 9 in a way that adds up to 10, I'm going to go ahead and use 9 times 1. In order for it to be a negative 10, they'd both have to be, subtraction. So my possible solutions are 1 or 9. This is the kind, though, that I do kind of like to go back and double check and see what would happen. So I just think, okay, if I put in a 1, square root of 4 would be 2. 1 minus 3 would be negative 2. So 1 does not actually work. So I'm glad I checked. And I knew to check because this one had the radical on one side in the original problem and not the other. And the other side had the x minus 3, not just a number. So how about 9? 4 times 9 would be 36. Square root of that would be 6. 9 minus 3 would be 6 as well. So it ends up that x equaling 9 is the only solution, and that 1 is what we call extraneous. On the test, you want to show all your work. You want to have this answer there so I know you got it, and then you want to cross it off to indicate that you know that it doesn't actually work in the equation. All right, the radical here is ready to go. It's just a square, so I'm going to square both sides. I'll have 5x minus 6 equals 49. And then I'm going to do elementary basic math. I'm going to write my 5 better, though. That'll be 55, and x will be 11. All right. And there I'm not really concerned about it because it was just equal to a number. You can always check your work. That never hurts. But you don't have to do it because there's not really going to be an extraneous root there. Here I started by subtracting 63. Then I'm going to divide by 7. So I have x cubed, not squared, equals negative 7. I'll be taking the cube root, which is totally fine because it's an odd index, and that's okay. The other thing is I will only have one possible solution because it's an odd index, and I can get a negative number. So on my calculator, I'm going to ask what is the cube root of negative 7. I could do negative 7 to the 1/3. Make sure that you have the negative in there. And you're going to get about negative 1.91 when you pay attention to the 2 decimal rule. Alrighty, here I'm going to take my 184 and add 11. It's going to be my first move. And when I do that, I'm right here. I can't see what this power was. I'm sorry. 5/7. Aha. And this will become 195. When I divide my 5 out of there, I'll have this equals 39. Now, to get rid of a 5/7 power, I'll need to multiply by a 7/5 power on both sides. So the 7's cancel, the 5's cancel, and I just have x plus 3. And then 39 raised to the, and then for me, I have to use parentheses. 7/5 power gives me 168.845-ish. So I'm going to go ahead and round that off right now so I remember to 0.85. And then I just have to take away 3 from my answer to get my x alone, 165.85. All right. So the answers to this were on the key that was posted, but this would at least give you an opportunity to be able to see where those answers came from if you're struggling. This one is going to square both sides, and it just looks fishy. So when I'm done, I am going to check my answers on this one. Those cancel, those cancel. So the problem itself becomes really straightforward. I'm going to go ahead and take away x to both sides. So I have 2 equals 2x minus 5. Adding that 5 over, dividing by 2, I get 3.5 or 7/2. So I might go up here and on my calculator real quick, take 3 times 3.5, subtract 5, and I end up with 5.5 on the right. And if I take 3.5 and add 2, I get 5.5 on the left as well. So I know that these two are equal, which makes this a legitimate answer. All right, this next one I have a 5th root. So I'm going to start by moving the 5 over. And then I'm going to need to bring both to the 5th power. This simply cancels out. And then I don't think my chart goes that far. So I have 8 to the 5th as 32,768. Wowza. Okay, take away 2 from that. So I'll have 3x equals 32,766. And then I'm going to divide out my 3. And x is 10, so 10,922, and that goes in evenly. I don't have a decimal answer for that one. Awesome. Alrighty, 8 is going to be one where I could potentially have extraneous because I'm going to FOIL this side in order to square both sides. This cancels out and becomes the easy peasy part. This is going to have to FOIL. So x squared minus 10x plus 25. Hopefully you don't need too much help with foiling. Now I have a quadratic, so I'm going to go ahead and move these two things over in order to get that quadratic equal to 0, because that's what I need to do when I'm solving quadratics. So I'll have x squared plus 2x minus 63 equals 0. I'm going to try to think of a way to make 63 through multiplication that will subtract to give me this 2. So I am thinking through my options, 9 times 7 will do the trick. And the way to get a positive 2 is to have a positive 9 and a minus 7. Meaning my two options are that x would be 7 or that x would be negative 9, but this was one of those kind of fishy ones. So I'm going to go back up and actually check them. On the left, 7 minus 5 would be 2, and on the right, negative 12 times 7 plus 88 is 4, square root of 4 is 2. So that one checks. That's a legitimate answer. On the left, negative 9 minus 15 will be negative 14. There's no way that can be equal to the right side because the right side is a square root, which has to come out positive. So because that one won't work, then that one is extraneous. Remember that term? And it's not a viable solution in the end. Alrighty, I'm just going to go ahead and add that 6 over to isolate the weird part, which is the 5th root. So I'll have an 80 over here. To get rid of a 5th power, I'm going to need a 5th root. Do I need a plus minus? No. Why? Because it's odd. So x plus 7 equals, and now I'm going to do 80, I'm going to find the 5th root of that. And that comes out to be 2.402. I'll hang on to that for just right now. Then I'm going to go ahead and take away 7 from that. And I'm getting x equals negative 4.597. When you go to round this to two decimal places, this 7 is going to round that up to a 10, which is going to round that up to a 6. but you still need to have that 0 because you were told to round to 2 places. So pay attention to those details. Okay, my first move here will be to divide by that negative 9, leaving me with this, and that would leave me with a positive 9. Keep in mind, to get rid of a 3 over 2, we'll need a 2 over 3 power. So x will equal whatever 9 to the 2/3 is. And so I'm going to use my calculator to help me out. And I'm going to end up with, hang on, I made a mistake. No way. I didn't raise it to the power. So 9 to the 2/3. And I'm getting x equals 4.33 when I round off to 2. Okay. Okay, here we have all the doozies at the bottom. So let's really engage our brains. And these are definitely going to be the ones that could have extraneous roots. This one's super duper hideous. So I'm going to square this side, and this side is going to be a complete nightmare because what's going to happen is I'm going to have to multiply it by itself, since that's what squaring means, and I'm basically going to have to FOIL this side. Sad face. This side's so easy, so I'll do this side. You guys do the other side. I'll wait for you. Just kidding. Okay, so first is easy, 2 times 2. Then this is going to be a minus 2 root x minus 1. The inside is actually going to be the same. Wouldn't it be lovely if they canceled out? But they don't. Then the 2 last terms, negative times negative makes positive. Root x minus 1 times root x minus 1 actually just gets rid of the root and leaves me with an x minus 1. Okay, so where's that put me? That puts me, I've got a 4 here and a minus 1 there. So my number part's going to be a 3. These two are alike but don't cancel. So I get minus 4 of them. And then plus that x hanging out over there. All right, so what can I do? Well, I can move this 3 over by subtraction and this x over by subtraction. And then I'll have 2x minus 8 equals a negative 4 in front of this. Now, okay, let's square this. You could divide by the negative 4 if you'd like to. Next, let's actually do that. That's more in line with what I said to do in class. So I'm going to have my negative 4 root x minus 1. The problem is I have to divide each piece by that negative 4. So this side, this one, and this one. So this cancels. This becomes negative 1/2 x. This becomes a plus 2, and then root x minus 1. Round 2. We got to square this. We got to square this. This side is going to entail FOILing. I'm struggling to write this, obviously. Okay, the right side is easy peasy. The 2 and the root cancel. So negative 1/2 times negative 1/2 becomes a positive 1/4 x squared. The outside, negative 1/2 times 2 is going to be a negative 1x, as is the inside. And then these make 4. Okay, now where am I at? Well, I have a quadratic, so everything needs to get to one side. So I'm going to take away this x and add this 1. So I'm going to be adding a 1 and taking away an x over here. So when all of this gets combined, I have 1/4 x squared minus 3 x's and then plus 5 altogether. Okay, so you can do that with a quadratic formula, or if you don't like this 1/4, you can multiply the whole deal by 4. And then it's not so terrible to factor. You're looking for 20 in a way that adds up to 12. So I would break that down into x with a 10 and a 2, because they'll make 20 through multiplication, and you can get a negative 12 out of them if they are each negative. So ultimately, my solutions are 10 or 2, but this is like the world's messiest problem. I 100% need to go back up here and look at my original problem and ask myself, what's going to happen if I plug in a 2? So on the left, 3 times 2 is going to be 6 minus 5. It's going to give me a 1. Square root of that will be 1. How about on the right? Well, 2 minus 1 is 1. Square root of that is 1. So 2 minus that 1 is going to give me a 1. So 2 is a legitimate option. Now I need to check 10. Keeping in mind that sometimes they both work, sometimes neither one works, and sometimes just one works. So let's try a 10. So 3 times 10, I'm just going to go on my calculator. 3 times 10 minus 5 gives me square root of 25, so 5. Over on the right, 10 minus 1 is 9. Square root of 9 is 3. 2 minus 3 is negative 1. Okay, this side was 5. This side is negative 1. They are not equal, so 10 is extraneous. Meaning, you got it legitimately doing the work properly, but it doesn't work in the equation, so